Hello everyone. So in this video, I wanted to showcase some of the features of my engine that I've implemented. So the first biggest feature that I have implemented is the 3D physics simulation. As you can see, there are a bunch of objects in the scene and they are all the physics body. If I hit the simulate button, see what happens. As you can see, objects are being simulated in real time. So yes. So if I wanted to create a physics body, what you need is and let me create an entity. Then let me rename it to cube physics. Okay. So let's change its color. So let me add an sprite renderer component and let's change its color to red. Okay, as you can see, it's now red. So now to add physics, I can create a physics component. As you can see here, physics component. Okay, now I have bunch of parameters of here, like the what should be the coefficient of static friction, what should be the coefficient of dynamic friction, what should be the coefficient of restitution, what is the mass of this red object. So I can set it to like 1000 or anything like that. It is in grams, so keep in mind. So it is a sphere radius. Sphere radius defines the if you want to add a sphere collider. So I need to set up this sphere radius. So I have a sphere object like this one. So if its diameter is 1 meter, then I will put here 1. If it is 2, then I will put here 2. That's all if I want to add a sphere collider. And here is a box collider dimension, which takes the half extent of the box. So as you can see, this box is 1 by 1 by 1 meter box. So I want to provide the half extent, so it will be 0 0.5, 0.5, 0.5 and zero point 0.5. Then I have the force direction. If I want to apply force to this body, what should be its direction? Reduction in x y z coordinates in world space, of course. So then I have these two toggles which says is the actor static, means whether it is a static actor where all dynamic objects will react with it, or whether it is a kinematic object. Kinematic objects are those objects that have similar behavior as the static objects, but they are movable. Okay, so and here I have bunch of settings for like adding box collider, adding physics sphere collider, adding mesh collider. There are many more colliders that I have not yet added, like capsule colliders, plane collider. Those things I have not added. So let's add a box collider. You cannot visualize these things because I do not have a debug renderer. So I am planning to implement that later. Then what you need to do is simulate it. So let's simulate it. As you can see, it is perfectly being simulated like this. Now if I want to change the restitution value, means if I want to make it higher, means restitution defines the bounciness, if you know that. So if I wanted to change it and add the box collider again, as you can see, it's way more bouncier now. It's going crazy now. Yeah, I can also decrease it like to 0.1, 0.1 maybe. Then I add the mesh box collider. So as you can see, the bounciness is decreased. Uh, s- so that's how you can add the physics component. You can add physics component to pretty much anything. So if you want to add force to this red object, what you need to do is select this object and select the force direction, in which direction the force will be applied. So let's make it in the positive x-axis, like this, to be on the positive. enter the positive x-axis. And okay, that's it. So let's add the force. So I can add force like this. We say it's force is being applied. Okay, so I want to add force in the y-axis, like negative. Let's add force in the y-axis. You can see it's being added like this. You can also add force to these planned objects, or you can add force to any object. So if I select this plan, and if I want to add, so like I want to add force in the z direction, and so let's simulate it and add the force. It's adding force. If I in the positive x-axis, see you can add it in the positive x-axis or in the negative x-axis. So using the force direction and the amount of force, you can do pretty much anything. So you can just write a script where you have a gun and you can fire some bullets, and you can specify the firing direction, and that firing direction will be the force direction where the bullet can go. So it has many possibilities. Okay, the next main thing, the main feature that I have in my engine is ambient occlusion. So before talking about ambient occlusion, I want to talk about the bounce lighting and indirect illumination. So what are those things? So in nature, uh, when light ray hits the surface, it bounces off and then again hits the surface and it bounces off like this. So in real-time rendering, we cannot achieve that effect because it is way too expensive. We have solutions for that in offline rendering, like ray tracing, where millions of rays are shot from a point, and if a ray reaches a point, then that area will get that color. And if a ray doesn't reach the point, then it will be darkened out. So we have solutions for that. But in order to achieve that effect in real time, we need to do some hacks or something like that. So one of those hacks is this ambient occlusion. What it does is it darkens the areas where light is having a hard time on reaching. So like as you can see, the area below this shade will be darkened because light is not reaching there. The areas behind these wires will be darkened because light cannot reach there. So ambient occlusion simulates that effect. By no means ambient occlusion is 100% accurate, but it has a good look to it. As you can see, this plant, this area is being darkened. As you can see, as I move the camera, uh, it is showing the darkening effect. If I move it off, the darkening effect goes away. But if I put it on the ground, then it has the darkening effect. So if I show you the ambient occlusion map, so this is the SSAO map. So ambient occlusion is being calculated and stored in this in the red channel in this map, and I'm using this in the final renderer along with my diffuse and specular lighting. As you can see, the areas where the light cannot reach is darkened, like the inner side of this plant mouth is darkened. As you can see, it is darkened, and all these areas are darkened. The like these areas are also darkened because light cannot reach here. Uh, Again, in the under below the shades is also darkened. So in this video, I'm not talking about the implementation of ambient occlusion. So in the later video, I'll be making, I will talk about how I implemented ambient occlusion and how I am using this ambient occlusion map, calculated ambient occlusion map in my shader for rendering the scene along with the specular and the diffuse lighting. So The next main component or the next main feature that we have is the addition of camera component. So if you have an entity like, what is this entity? Okay, so I have this entity. So if I wanted to attach a camera component here, so what I will do is add a camera component, create a camera component like this, and I can attach a camera component. As this object is way too big, so it is covering up the camera. So I can move the camera back like this, move the camera back like this, move the camera on the x-axis or on the y-axis. So I have a toggle for whether this camera is a primary camera or not. So if this camera is a primary camera, then I will switch from my main editor camera. See, as you can see, I cannot control it. I cannot control it to this camera, this object's camera. Uh, so I have some of the settings like which camera projection to choose, like orthographic or perspective. Orthographic projection is not yet mm, set up perfectly. As you can see, it's bugged out. It is bugged out. It is not set up properly. Then I have settings for the FOV. It should be FOV, field of view. It should be whether I should make it lower or higher. FOV. Make it 90. Then I have settings for the near and the far distances of my camera. So yeah, if I increase the near clip, as you can see, the increase everything in front of the camera will be clipped out and it will not be rendered. So this is 0.01. And this is the far clip. Far clip defines at what maximum distance things will not be rendered. Okay, so I also have this toggle for following the player. If I, as you can see, it is on. So if I move the object like this, it will move. If I move it up, if I move it on the z-axis, it will move. If I rotate it, when the camera will also rotate. If I rotate it in the y-axis, the camera will also rotate. So if I toggle this off, then the camera will not follow this object. You can see, will not follow this object whatsoever. So yes, this is the handy feature that you can use in the script to manipulate the camera. So the next feature that I want to talk about is the scene serialization feature. Now my engine has a support for saving the scene, saving the work that I have done into a file, and then you can load that file from the disk. So suppose if I want to add an entity, uh, set an entity, and set windmill file. So as I have added this entity, so I need to save this. So what I can do is just save it using this save button. I saved it. Now it is saved in the disk. So let me change something else. Let me add uh, slice in the component and let's make it. Uh, so as you can see, I have a violet cube. I did a violet cube and this windmill mesh. So I will save it. So, and I will close the application. Now, as you can see, this is my saved file. So saved scene.az. So here it contains all the scene information. As you can see, it is the name of the scene, number of lights, point lights that I have. Then what are the entities that I have? So this is the entity UUIT, and so this is a tag component, the name of the entity. So this is a transform component, construction rotation scale. Then I have the spike render component. So this is the spike render component. I have the static mesh. So you can see it stores the mesh path. Like this, I have all the entities stored here. So if I start my scene, so I just need to click this load scene button and I will get back my scene. As you can see, this is the scene that I have. So here is my windmill, here is my violet cube. So how I implemented those things. So let's take a look at that. Um, so I have the scene serialization class. So here I have the serializer function, and I'm using YAML for storing everything. So I'm just initializing the YAML and beginning a map. Then I am iterating over all the entities. So I take this entity and check if it is a tag component or not. So if it has a tag component, so I serialize it. If it has a transform component, I serialize it like this. I do for each and every components that are supported in my engine. So the next feature that I've implemented is the scripts, addition of scripts. Now you can add custom scripts into my engine. So as you can see, I have added a custom script here. So each and every script that you add must inherit from the scriptable entity class. So if you want to make a script that makes a that is a firing script, then it should inherit from this scriptable entity. So what this script does is, so I have bunch of checks whether the button is pressed or not. So if I press any of the buttons like WAST, then my object will move forward, backward, left, and right. If I press E and Q, then it will rotate. You can say I'm just doing it rotate. So yeah, after everything is done like that, I am just updating the transform component of that mesh with this new position and this new rotation variable. I also have two functions like onCreate and onDestroy. These are called when the script is being attached, and onDestroy is called when the script is being deleted. So let me run and show you how to add the script. So in order to add a script, so I can add script to any of the existing entities. So as you can see, uh, in the script component section right here, it says minimize these things. In the script component section, it says that it doesn't have a selective script. So if I add this add custom script, then the script will be added. It is true for this here too also. It doesn't have a script. So see, doesn't have a script. So you can add script to pretty much any entity. Any entity can have a script. So in order to add a script, let me add a new entity. Let me add a new entity. This is a script entity. So let me add a color to it. Uh, so let's make it somewhat bluish. Right? So as you can see, it doesn't have a script. So let me add a script. And so as I added a script, as you can see, if I press WASD, then it moves. So if you want to see it clearly, let me add a camera component. And as you can see, it is moving forward, backward, left, and right. Okay, I can also rotate it like this. So yes, as you can see, there is a flickering of colors. So This is happening because I have two entities that are having the same script. So one is having so one of this is this Q entity. It has script, as you can see the script. So if I change the color of this entity to say red, you can see it has there are two entities that are sharing the same script. So this will happen because both are sharing the same transform. If I move the camera, rotate the camera like this, you can see. Yeah. So these are all the features that I've implemented into my engine. As you can see, the UI is not that great. If I show you the physics UI, the physics UI is not that great because everything is cluttered here. So I didn't wanted to make the UI look good because I didn't wanted to waste the time there. So that's why it's not that great. That are the features that are there. And thank you for watching and see you on the next video.